Welcome in again. Here we are with another video demonstrating some of the capabilities of the database. I did this the other day for a demonstration, and I thought this would be great to show. It demonstrates two things in particular: going overhead to underground, possibly inducing rigid into the mix. For example, going up a chiller or something like that, you're going from inside to outside. Just show real quick that we do have the database website here. Be sure to check that out. It's Keystone Electrical Consulting LLC.com. I will put the link again in the comments so you can just get to it pretty easily that way. So after today, you'll probably find that this is a pretty powerful solution indeed, and you'll want to get your hands on this for sure. Half this speed is because of this environment. So that's one thing just to say off the bat. If you don't have this database, you are not going to be able to recreate this anywhere near this. So we're going to start with the branch EMT spec here. In the specification, I've got all my automatics on, and I've got my strapping from starting with the EMT from inside to the outside portion. I'm just going to grab branch assembly right here. And I'm not going to use live count for this example because I don't want to induce any of those other equations in and take up more time. We'll just throw some common stuff in here. My conduit length, which of course we would measure in live count if you needed to. You'll see an advantage from most any other database is my horizontal is 100 feet that I just plugged in here. I have this drop length induced into my environment, which a lot of people like. This is a total add of what you need, meaning if I need 10 foot coming up out of the panel, then over to the wall, and then down to get to the PVC that is eventually that we're going to put in here to go outside. Then I need another 10 feet on that other end, then I would put a 20. So all I'm trying to say, this is an adder of all things that are a drop length. And it is that way in case you did want different lengths. If you wanted 8 feet over at the panel and then say 15, then you could just put that addition in there. So that's why it's like that. I didn't want to pin it so it just does the same length twice because you might not want that. And then this has a vertical attachment, which you can also do separately. There's lots of options here. We'll do strut on drywall for the heck of it for this one. But as you can see in that drop down, there's lots of different options you could do. If you don't want anything, there is actually a none. This will get us the EMT from point A to point B, and then I'm going to go immediately to the details here. The reason I'm doing that is it's going to keep everything into the same bucket. It's going to identify to me that all these other accessories go with this unit. That's one thing I try to do, is bundle everything together so there's not just all these random takeoffs in the audit trail that I don't know that they go with this one unit. That's really the key there. This is definitely my methodology when doing this. If I drop this down, you'll see there's my EMT. I've got all my correct stuff there. I've got a junction box here. Now, if I didn't want that, I could uncheck this junction box icon over here, and I might do that for that example. And I would always do it while I see the OK and cancel in this edit mode. I wouldn't have done this before I entered this. So that's kind of a technique too. The reason for that is because then once I hit OK, then this box will go back on. And that's kind of the technique there. The reason I did that is because I'm going to hit a junction box here, and I want to put a little bit different type here. So maybe I'll do a NEMA 1. Here's all the different sizes. You'll notice this junction box assembly is also very much different than what you would see in most any other environment. Maybe we'll just say it's on a concrete wall. I'm going to throw that box in there instead. That's going to be my transition box from outside to inside. Where we really get into the big difference of my database versus anything else, a lot of you would be saying, well, if you're going to change from EMT to PVC, you must have to change the specification because it's a different material type. Under normal conditions, yes, but I acknowledge the real world here The reality is I'm stuck in this environment that I say I want this to be the end all be all bucket for everything. So I cannot change the spec midstream like this. I've built in an efficiency where I've got this PVC in slab. There's also a trench version of this, which you could swap this out for that if you wanted to. So the big difference here is it asks you what the PVC type is, so you don't need another spec. So you can do these all seamlessly together. And this is one thing that this database has solved. It eliminates all those little hiccups of changing materials for scenarios like this that you have to bulk together. You can just do them all at the same time. So I'm just going to say schedule 80. It remembered all of that. Now I'm going to say when I'm stubbing up into that box that I just put in there, we'll stub up with PVC, I suppose, there, because it's probably going to be in a wall or something like that. So I'm just going to say it's a PVC with a male adapter. You could choose a bell end, a couple other things if you wanted. So lots of choices there too. Now the other end, we're going to say that's going to like a chiller outside. So I want a GRC stub up there. We're going to say RMC. This transition length is that piece that comes up out of the ground. I'm okay with 4 foot here because I'm going to address anything at the chiller. If I had to go up 20 feet to where the disconnect actually was or something like that, we're going to address that in a minute. We're going to induce another material type into the mix. I'm going to leave that there. I'm going to put a grounding bushing on the end of that RMC, which is probably what you do anyway, so we even thought of that. We're going to say no elbows. We just went straight out. There's my PVC in slab. Now I've got my EMT branch. I've got my junction box before I go outside. I've got my PVC. If I toggle that down, you can see PVC couplings. My primer and cement's all auto-calculated. I got my wire. Got everything. My stub ups are down here. Here you can see there's my 4 foot rigid, which we said was on the one end. And then if we go up here, we should see a 4 foot of PVC as well, which right here, that's the stub up. That's one thing to keep in mind. Those are kind of separate so you can see them. And then the length of the 100 feet here going outside. And I could have changed that as the same length. Let's do that real quick. We don't want that the same. We're not going to say it's 100 feet to the building and then another 100 feet out, although it could be. But just to show that we can change it, we'll say it's 40 feet over to the chiller. That's fine. To recap, once more, we've got EMT to the wall, down the wall, junction box, out with the PVC, stubbed up. Now what? Now I'm going to hit the junction box assembly again, and in the same assembly, I can say, well, I want a NEMA 3R box, and because I'm going to set that at the base of the chiller, then I'm going to say it's about the same size. And then this one, it's going to mount to sheet metal because it's probably some kind of metal structure. If I toggle that down, I can see, in fact, I've got the 3R box, some self-tapper screws, a washer for the screws, and we're going to just screw that thing right on there. So that's good. I like it. Now out of that box, perhaps we just have to go out of the box horizontal to where the disconnect's going to be and then connect to the disconnect. I'm going to grab this up here. It's a GRC and I'm doing it all on this pad. I'm not going looking for assemblies and building assemblies and then sitting here thinking, well, what am I going to do? And there are different versions of this rigid one too. This is just on concrete, but you could swap that out for different ones or add other ones as well. We'll say this length is just 20 feet. That all looks good. I'll hit OK. When I get to the end of that rigid, perhaps I want an LB. I'm going to dead end that conduit, put an LB, and then I want a flexible liquid tight motor connection. That's what we'll do here. So we're going to grab this LB. We'll put one of those in there. And then we're going to grab this liquid tight connection. I put 3 wires, so we'll put the 3-phase. That's all fine. And that's pretty much it. I like that. We've got our EMT, our inside junction box, PVC, outside junction box, our rigid over to the disconnect, and our motor connection. One thing I don't do, here's one thing that I'm going to stop just technique-wise and say, am I going to put the disconnect in here? No. And here's why. Typically because I count the disconnects off of a mechanical schedule, usually. Then if an addendum comes out and I have to change it, I don't want that buried inside of here, because if I change things like wire sizes and stuff like that, I can do that kind of stuff globally. But the disconnect, they're hard to find when they're buried in here, especially if you count them off of one mechanical sheet. I want them all in the same place so I know where they are. I would actually end this assembly right here and say that's done. And you'll see why I'm saying this too in about a couple seconds here. But just so you see how this rolls together, if I hit the plus sign at this level, and there's a little magnifying glass symbol right here, I can click that. You can see how this systematically goes down through and it has combined everything I did. So there's the EMT. If we go down here a little further, there's that junction box. Then you can see here our PVC is right there. And now you see why I utilize that details tab so much, because it didn't throw this stuff in all kinds of different places like I was saying earlier to where I'm lost in the mix. This combined everything so I know what the whole unit is, which is great. So then how do I manage the disconnect? Well, I live and die by these systems. So there's a disconnect system there, and then I got my disconnect assembly here, which perhaps I'm going to say, I use number 10, so maybe I'm just going to say it's a non-fused 3-pole disconnect. It's a 30 amp. It's a 3R because it's outside. We'll say that's on sheet metal, and quantity 1. I like these being where I can get to them and change them if I have to easily. If you're doing a bigger job where you've got a lot of disconnects, you don't want those all scattered amongst all those different mechanical takeoffs. You would want them here so you know where they are. I didn't change any specs, barely broke a sweat there, and did a pretty complex scenario fairly easily, I would say. So that's really the power of what we've got here. It makes takeoff like that very easy, very streamlined thought process, and not really getting too complicated with anything. One spec did it all, and it got me right to the end. Until next time, I'll try to keep these going as I said. Be sure to check out the site. Reach out if you want the database. We're here to support you. We can solve all your woes and get you cranking on this thing. Thank you for everybody that has bought the database. I appreciate y'all. Thank you very much. See you next time.